Okay, go play now, Abby. All right. So I still have the graph up of the one we just did in the last notes, and we talked about how this is a parabola. It's still gonna be a function. We're gonna talk about why later on, but it's not a linear function. It doesn't form a straight line. Now this equation here, function y equals x to the second power. That can actually represent a formula we know pretty well. So that's going to come in right here. It says the area of a square is a function of the side length of the square. So if I had a square here and I wanted to find the area, remember the area of a square, a rectangle, or anything, if I called it S, would be S times S. So that would be the area equals S squared, S to the second power. Area equals side length squared. And if you look right here, this is kind of the same thing, y equals x squared. So remember, variables really don't matter, okay? We can use this one for a lot, but this one is usually used to represent the area of a square. So use the function you wrote in part, C, to determine the area of the square with a side length of 2.5 units. All right, so my side length is 2.5. Write your input output as an ordered pair, and that's going to be important because I'm going to expect you to do that in your homework. All right, so here's my function right here. A equals S to the second power. My side length is 2.5, so my area equals 2.5 to the second power. Now, whether you grab a calculator, so I can make it a little neater, and write 2.5 times 2.5, because that's what the squared means, or you go 2.5, raise to the second power or hit the square button, it's going to work out to be area equals 6.25, okay? And it's units here, so we're going to say square units. We'll talk about later why that is. Now, writing it as an ordered pair, though. Well, how do we write an ordered pair if we have A's and S's? Well, remember, our S here, our input is our X value. Our output is Y. Okay, so our A is our output. So if I wanted to write an ordered pair, what is my input? Well, it's what I put in for S. In this case, 2.5. Okay, so that's input. That's what comes first when you're writing things here as an ordered pair. Then is our output. When we say Y, it's our output. And well, our output is 6.25. If I can spell correctly. Okay, so I just want you to write it as an ordered pair. That's all that really means. Okay, input is your X value, output is your Y value. If we wanted to look up on our graph, if you went to 2.5, so it'd be right here. Okay, notice that here's 6, here's 7. It's kind of like right in here, right? Notice that that's going to fall on, if I can draw it, okay? It's going to fall on that curve if I were to draw correctly and not make everything way, way, way uglier than it needs to be. It's going to fall on the graph. So even though it's not linear, it doesn't change the fact that when we're solving these functions, that relationship, whether they're x's and y's or a's and s's, they're represented on the graph. Okay, that's how we represent all the possible solutions. Okay, so now let's talk about graphs and functions. It says examine the 3 graphs below. Which, if any, could represent the graph of a function, and then explain why or why not. All right, so if we look at this one right here, if I were to list these ordered pairs, okay, let's get my cheat sheet here to make sure I don't mess up. This right here would be -2, that's my x value, and 4. This point right here would be the point 0, because I haven't left the y axis, 3. This one would be 2, 2. That's that one right there, sorry. This one right here would be 4, 1, because I go over 4 and up 1. This one right here is 6, 0 over 6, not up and down at all. And right here we have 8, -1. Okay? Sorry about the sloppiness, that as always. So remember, functions mean, well, I'll write it down here. Every input has exactly one output. So when I input -2, I get 4. When I input 0, I get 3. There is no other like 0 number here that I put in and get another one out. If I input 2, I get out 2. If I input 4, I get out 1. If I input 6, I get out 0. And if I input 8, I get out -1. So when we're talking about, is this a function, we could say, yep, this is a function. Each input has exactly one output. We've written that before, right? Okay. Each input has exactly one output. So let's look right here at this one. Okay, so this point right here, or I'm sorry, there's one here. This point right here is 0, 0. This point right here is the point 2, 3. This point right here is 4, 5. This one right here is 6, 6. And this one right here is 6, 4. This point is 7, 2. And this point is 9, 1. Okay, so now if we're talking about is it a function, we're thinking every input has exactly one output. So if I input a 0, I get out 0. If I input 2, I get out 3. If I input a 4, that's a 4 there, I get out 5. If I input 6, I get out 6. If I input 6, I get out 4. Red flag. Okay, if I input a 6 right here, okay, I get out either a 6 or a 4. All right, there's nothing wrong with that. That just means it's not a function. Okay, so we're going to say not a function. And we'll say the input 6 has two different outputs. Okay, and our definition of function says, hey, whatever we input, we only get one output out. Now I want you to notice how these line up right here. Okay, notice that both of them lie on the same vertical line, which is going to lead us, which I'm going to type, it's going to lead us to something called our vertical line test. And this is really nice to have when you're when you have a graph and you have to figure out whether it's a function or not. If any vertical line intersects more than one point in the relationship, it is not a function. All right, so our vertical line test here says that if any vertical line intersects more than one point in the relationship, then it's not a function. So if we look up here, notice that if we pass a vertical line along here, it hits 2 points, which means it's not a function. So we can also, with graphs, use that idea of a vertical line test. So let's say I take this line right here, see if I can move it. Okay. And if I move this line, pretend it's really vertical, notice, sorry, it's going to have this thing, whatever, in front of it. Notice, though, it hits all the points only at one time. Okay. So we have a point here, 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 and here. And if I run this vertical line over it, it's going to hit the points only at one time. So if it only hits them at one time, it's a function. And that's what we can say. We can use that now for explanation. Function, it's a function because it passes the vertical line test. All right, so we can also use the whole passing or failing the vertical line test. If I were, see if it'll let me here, take this vertical line, maybe, up here, you would see, maybe, hopefully, that this line, when we run it over it, it fails the vertical line test right there. That vertical line hits in 2 spots. So we could say not a function, not only because the input 6 has 2 different outputs, we could say it's not a function because it fails the vertical line test. Okay, if it hits it in a vertical line, only a vertical line. If it hits your graph in 2 spots, then it's not a function.